This meeting is being recorded.
Our next topic is averages. What counts as typical? If we have a bunch of numbers, what's one single average kind of number that will represent the others in a fair way? So this is not something that has a good answer just in English. So part of what we're doing is saying we're doing math. We need to have more agreement on some kind of official answer than just English does. So here's the situation that we can argue about. And it's a shame that it's just us, April, because this would be fun, but other people were busy tonight. So there are these things called pattern blocks. I have a whole little tub of them that I can hold up to the camera. Did you ever play with these, or your kids played with them?
Yeah.
So they come in different shapes. That little green triangle is the smallest. If I have two green triangles, then I can move them on top of a blue. You can see they're the same size as the blue. 3 green triangles makes a red. 6 green triangles makes the yellow. And I could weigh them and see about what they weigh. So the first question to argue about is, what's the typical weight of the blocks in that group? And there's no one right answer to this. What do we mean by typical? In English, this isn't like a one right answer kind of thing. Different people could defend different answers. What would you pick as a typical weight of a block?
The typical weight? I don't know.
Yeah.
In the group to the left. So from over here.
Again, the green ones each weigh 1.5. The red ones each weigh 4.5. And the blue ones each weigh 3.
Okay. Three.
3 is a common answer, and most of them are blue blocks, so 3 seems like a typical answer. What counts as typical? There's 3 common ways that people answer this. What you did, I'm guessing, is what appeared most often. So blue was most of them. It's the thing there were the most of, so let's use the blue weight, which is 3. Other people think differently. They think we're going to say if something doesn't appear often enough, that doesn't count. That's not a good representation of the whole group. So if there's just a little bit of it, we'll toss those out. And that would be the same thing here. We would say, oh, there's just not very many of the greens or the reds, so we're going to cross them out, and the blue counts as typical, and the blue is 3. We get the same answer, but kind of a different rationale for why we get there. It's not because we're just picking the one there's the most of, it's because some of them are disqualified. And the last one is, some people have been taught in other math classes, add up the values and divide by how many. If we were to do that, we would have 2 1.5s. We would have 1 4.5. And we'd have a bunch of 3s. How many 3s? 1, 2, 3, 4, 5, 6 3s. 6 3s is 18. I'm doing that just because I can't fit it all on the paper if I'm just trying to list 16. Notice with my 18, I'm lining up the decimal point so that all the decimal points are there. All my ones column, all my tens column, all my tenths column, right? When I do math, I have to line up the columns, right? So 5 and 5 makes 10. In this case, it's a half and a half makes a whole. 8, 9, 10, carry 4 and 1 is 5. 1 and 1 is 2. And then 25.5, how many were there? 1, 2, 3, 4, 5, 6, 7, 8, 9. That one I'm going to use the calculator for. I get 2.8 about. So if we add them up and divide by how many, we often get a decimal answer and not a whole number, which is a little different than the first two philosophies where we just picked 3. But that doesn't mean any of those is wrong. We can defend any of those options. If we had more people with us, then I'd say, oh, somebody put in 2 yellow blocks. Now what counts as typical? And again, we could argue about if one of these 3 options philosophically makes more sense than the other. As math class people, we aren't interested in trying to solve this philosophy or English language issue. We just want to know what we're talking about. So we're going to use one word, mean, to say the process we just did. The mean of a group of numbers is the add them up and divide by how many. It's the type of average you probably have seen in a previous math class somewhere in your life. And if somebody just say average, it should be safe to assume, unless they're trying to lie with statistics, that they're talking about this mean, this kind of average. They add them up and divide by how many. So in a certain preschool classroom, the students' weights are all of these numbers. There's one student that's 34. There's 3 students who are 36. 1, 2, 3. 2 who are 37. 1 who's 38. There's 2 who are 39. 2 who are 40, and the last student is 41 pounds. What's the average weight of those 12 students? So I'd have to add it up. 34 plus 36 plus 36 plus 36 plus 37 plus 37 plus 38. Only one of 2 39s. 2 40s and a 41. Oops, not 11. 41. There we go. So 453. So the sum was 453. Then divide by how many? So it says there's 12 of them. So 453 divided by 12. So 37.75 pounds. If you wanted, it would make sense to round it. It's about 38 pounds.
That's all together.
Yeah, so it is saying that a typical student weighs about 38 pounds. So where is that on the chart? It would be here. And the way that these bar charts work with this kind of average, the one called a mean, if you were to think of it like a teeter-totter, it should look like it balances on the average. Does that look reasonable, that there's as much stuff on that side of the teeter-totter as there is on the other?
No.
No? Oh, okay. Well, sometimes it does, and then you can feel more like you. There's a different kind of average called a median that people don't talk about as much, but it's important. To find the median, you're going to sort the list of numbers if it's not sorted already, and then just simply pick the middle one. If there's an odd number of things, then there's just going to be one in the middle and you pick it. If there's an even number of things, then two of them are in the middle. And you have to take the average of those to add them up and divide by how many, the mean kind of average. So let's see why we need to do this. Remember these preschoolers? Let's say that 3 of them have their favorite stuffies and insist that they be included also. So 1 and 1 and 2. So we're going to go back up to here and add 1 and 1 and 2. Now we get 457, and we have to divide by not 12 students, but 15, because we have the 3 stuffies also. So now we get about 30 pounds. And we got that again because of 457 divided by 15. So again, we used to have 453 divided by 12. But the 453 went up just a little bit because the stuffed animals don't weigh much. And the 12 went up to 15 because we have 3 more stuffed animals. And if we look at 30 pounds, instead of this nice thing here, now 30 pounds that's like way off over here on the graph. All of the preschoolers weigh more than 30, and all of the stuffed animals weigh a lot less. So this number is terrible as far as trying to represent that data. Nobody is about 30. Everyone is either more or less. So this is okay math. We didn't make any mistakes. We added things up and we divided by how many. This is just a correct answer to a stupid question, because you can't really combine preschoolers and stuffed animals and say, what is the mean, to add them up and divide by how many and expect anything to make sense. But the median is what we want. So let's clear up our page a little. Okay, if we list them all out in order, so we have the 1, the 2, the stuffed animals, and then the students. And then we pick which one is in the middle. Oops, I'm writing 14 when I should write 41. Okay, let's go to the middle. So not that one and not that one. Not that one or that one. Not that one or this one. Not that one or that one. Work our way towards the middle. There we go. That's the middle. So now our answer is 37 pounds. That's good. If we look back at this thing, 37 looks like a nice typical weight. Some of them are more, some of them are less, but that's an answer that seems okay. It represents this data much better than the 30 did, way off over here on the side somewhere. The students had 38. This went down a pound because we included some tiny things, but it didn't go down too much. This 1 and the 1 and the 2 that were so bizarre, why are we including stuffed animal weights? We just sort of crossed them out. Similarly, what if we had this 41? What if it was the teacher that weighed 141 pounds? It doesn't matter, it just gets crossed out because it's on the edge. So anytime you're looking at a bunch of numbers and the ones that are very big or very small don't matter, they are not representative of the group, that's what this median is for. Make the list and pick what's in the middle. The median ignores the most extreme. That's the kind of thing you use it for. So why do you care? Well, company salaries. Is this a good company to work for? It doesn't really matter what the CEO earns. You're not going to be the CEO. You just care about the people in the middle of the company, right? Or state incomes. And you're wondering, does the state have a high cost of living or not? Then you don't want to include the very biggest numbers, because you and I aren't going to be the biggest earners in the state. And all the people that are on food stamps, we're not going to count their income because hopefully we're working and getting a little more money than that. So by tossing out the ones that are very small and very big, we get a number that's sort of what most people are like. So salaries, incomes, neighborhood house values. If you and I are neighbors and you inherit a lot of money and get granite countertops and a fancy driveway and all sorts of things like that, does that make my house value go up? A little bit, but not much. The biggest house and the worst house in the neighborhood have some effect, but not a big effect. So all sorts of situations like that, we're going to toss out the smallest and the biggest and pick what's in the middle. So that's what the median does. Both of these are, again, mathematically correct. It's just which situation do they make sense in? So things to think about over the weekend. What are other situations that it makes sense to use the median instead of the mean? What are things like salaries and incomes and house values where the biggest and the smallest don't count or shouldn't count if we're talking about it? They're a distraction from the real issue we're trying to solve.